Welcome to our next lecture of non-destructive testing. My dear students, this is Salman, Assistant Professor, Department of Mechanical Engineering, ISL College of Engineering. So, in last first unit, we have in non-destructive testing, we have studied about liquid penetration technique and magnetic inspection technique. So, in this technique, in this chapter, we are going to discuss in unit 2. We are going to discuss about eddy current testing. So, what is the principle behind this? What is lift-off factor? What is edge effect? What is skin effect? Incident frequency, coil arrangements, or how we are going to do the coil arrangements in eddy current testing. What are the various types of inspection probes which we are generally using in eddy current testing? Types of circuits, what are the types we are using? Reference pipe pieces. What is the phase analysis, display method? These are the test things we have to discuss in eddy current testing. So first of all, let us see what is eddy current testing. So it is one of the electromagnetic non-destructive testing principle in which we use eddy current. That is nothing but when you are passing an electric current through some device, if there is a magnetic field which is generated because of electric current, because if you are trying to break the electric field every time, if you are trying to break the magnetic field every time, there will be a generation of current. That current is nothing but called as eddy current. So we'll see that that eddy current testing works on a principle of electromagnetic induction. Eddy currents are introduced in a test object using alternative magnetic field. So if you are changing the magnetic field every time in a test object because of the change of the electromagnetic field in the, for example, if there is a device like this. So if you are, I will try to zoom it so that you can able to see properly. So let us see the device. So if this is my test object, so what I will do is along the test object where I have to measure the flaws or discontinuities, along the discontinuities I will be having a device on which I am passing an electric current like this. So this is generally called as probe. So to this device I will be bringing near to this test material, bring this close, take it away, bring it close, take it away, bring it close, take it away. Because of that, when it breaks the magnetic field, there will be generation of electric current inside the device. There will be generation of electric field inside this device, test device. This electric current which is generated in this device is called as eddy current. Okay, so the flaws in the test object changes in eddy current and the flow pattern. Because of this changes and because of generation of this electric current, the magnetic field which is passing through, because when it again generates the magnetic field, because of when it generates the electric current, because of the electric current, again the magnetic field will be generated around it. So this magnetic field will be opposite to the magnetic field which is generated because of this. So these two magnetic field try to nullify. So this change or this subtraction, the resultant net magnetic field will give you the direction of the flaw and the where the flaw is present, how the flaw is going to be change, how the flaw is going to affect the magnetic field. In this way we are going to study. Okay, so ECT is usually used to detection of surface and subsurface detection in conduction materials only in conductive materials we can do this. Okay, this method is complementary of ultrasonic testing for detection of flaws close to the surface. So before entering into the further topics, first of all we have to identify what is electricity, what is conductivity, what is resistance, what is conductance, what is permeability. So electricity is nothing but the movement of electrons. Everyone knows this. What is conductivity? Conductivity is nothing but the ability of a material to pass through the current through this. Resistivity is nothing but the opposition of flow of electrons or flow of atoms through a material. Conductance is nothing but the ability of the particular component to conduct the electricity. Permeability is nothing but the same, whereas conductivity is the ability of the electric current. Permeability is nothing but the ability of a material to allow the magnetic field to pass through this. Okay, so ampere is nothing but the amount of current or the flow of current. Ampere is generally we even use as a unit of current. Volt is nothing but the amount of charge, that is nothing but the electromotive force required to move the one electron from zero state to another state. That is nothing but electrostatic difference is created from 0 to 1 or 1 to 0, whatever it may be. So when you try to create the electromotive force required to move an electron from 0 to 1 volt, that is called as volt. Next, Ohm's law. Ohm's law, everyone knows that the current is directly proportional to resistance. Sorry, voltage directly proportional to current, where R is the resistance of the material. So according to Ohm's law, V is equal to IR. Next, current density. Current density is nothing but the amount of current passing through a specimen per particular area. Induction is nothing but the process of establishing of an electric current in a conductor by placing it in a zone of changing magnetic field. Inductance. Inductance is nothing but how we are going to charge the conductor by keeping it in a zone of a magnetic field. If you are bringing some object into a magnetic field, so the object will get magnetized first. Because of the magnetization, again there will be a generation of electric field into it. So keep this, remember, every time when there is an electric field, to the electric field there is a magnetic field. Whenever there is a magnetic field, there is a electric field, obviously. Okay. Next, electromotive force, the force required to move an electron to a prescribed distance, okay, within a within the conductive material. Electrical impedance is nothing but the total, just like resistance. Resistance is the opposition to electric force, electric field. Similarly, electrical impedance is nothing but the opposition of a conductor to allow the alternating current to pass through this. Alternating current is nothing but AC current, which can be moving from 0 to 1, 1 to 0. So it can have a negative or positive. DC will always have a stationary current, whereas AC will be like this. AC, everyone might have seen AC current. So if the AC current is like this, means it will be like a sine wave. 0, 1, 0, maximum, maximum, minimum, maximum, minimum, like this. Next, inductance. Inductance is the effect produced on the flowing current by induction on an electric circuit. Lenz law. Lenz law is nothing but when you are having a, when an object is breaking the electric field or magnetic field, because of the breaking, it will be get magnetized or electrized. So because of, generally it is said to be magnetized. When it becomes magnetized, there will be a generation of current which tries to oppose the naturally, or which tries to oppose the magnetic field which is already present. So this is called as Lenz law. So let us state that Lenz law states that the induced current, induced is nothing but which is going to be coming because of the other magnetic field, has a direction such that its magnetic field opposes the change in the magnetic field that induces the current, because of which the current is generated. It tries to oppose that. For example, I am trying to give you some amount of current. I'm trying to give some magnetic field to you. Now, because of the magnetic field inside you, there is generation of some current. That current will try to oppose the current which I have produced. So the secondary current which is generated is trying to oppose the primary current. So this type of opposition, or this type of current, is called as eddy current, and this law is stated by a Lenz. So this is called as Lenz law. Okay. So eddy current, when there is a relative motion between the metal conductor and the magnetic lines of forces. For example, if you take a metal conductor and there is a magnetic field around some permanent magnet, and you are trying to bring the electric conductor into the magnetic field and away from the magnetic field, into the magnetic field, away from the magnetic field. Because of that, there will be generation of electric current inside the surface. So this type of current is called as eddy current. So what are the properties of the eddy current? If you see, and the eddy currents are closed loop of induced current. There is nothing but it is induced in the object where it is being, which is being moved front and back. Okay, it is always perpendicular to the magnetic field generated. So since I have told there is a permanent magnet, around this there is a magnetic field. So around that magnetic field, when you are bringing the metal conductor in and out, because of this motion, so the magnetic field and the current generated in this will be perpendicular to one another. So they normally travel parallel to the coil windings, and the flow is limited to the area of the induced magnetic field and perpendicular to the axis of the coil. So eddy current decreases exponentially with the depth. So when you are bringing close and taking away, when the current is generated at one end, the other end it will be less, and that less is nothing but it is by ratio of exponential value. That is called as skin effect. So this is the principle. So what I am doing here is I am having a series of wires. So where there is a passage of current, AC current, because of that AC current there is a magnetic field generated. What I am trying to do is I am taking a substance test object on whom I have to measure the discontinuity. I will bring this close to the surface like this, taking this close away, take close away, take close away, take close away, take close away. Because of this, what happens means the direction of magnetic field, according to Fleming's left hand rule, you can able to identify the flow of, what we say, magnetic field. So that we are going to obtain. So that they have written that the direction of magnetic field is in the downward. So because of this, there will be a generation of magnetic field in this, which will be opposite to this magnetic field. You can see this. So both are in opposite direction. So now this is getting magnetized. So since when this magnetization is happening, so according to that there will be a generation of, what we say, electric field around this. Eddy currents are generated around this circular device. So these eddy currents, this because of the presence of some discontinuity, this current which is generated is this induced in this will have some kind of disturbance. Will have some kind of disturbance like this. So basing on that, we can able to identify where the discontinuity is present, at what depth it is present. So let us see the stages. So the first stage is we have to generate the magnetic field by sending some kind of AC current. Second stage is we have to induce the magnetic field or eddy current into the test specimen. Okay. After sending that, what we have to do is eddy current flowing in the material will generate their own secondary magnetic field which opposes the primary. So since the eddy current is generated in this, it will try to generate a magnetic field which tries to oppose the primary magnetic field which is generated in this coil. Okay, so which has an effect to the coil impedance. Impedance is nothing but opposition to the flow of current in the coil. Okay, so how because of the flow, so here you have to remember, so since this is the AC current, the resistance to this is nothing but impedance. So because of this magnetic field, there will be a resistance in negative current which is generated in this coil, which tries to oppose the current which is being sent by this AC source. Okay, so that is nothing but impedance. So when a discontinuity is introduced in the conductive test piece, the eddy current are disrupted. So like this, the eddy currents are disrupted, which can be studied by using some instrumentation. So what are the advantages of eddy current testing? It is a high speed, it is accurate in measuring the conductivity, it is the discontinuities at or near the surface can be reliably studied. This technique can be generally automated because passing a current on the test piece has to become up and down, so we can connect to some mechanism. So where the test piece will be moving up, down. So with that we can able to identify the flaws. So no physical contact is required. It provides an immediate results of inspection. Low cost, portable means it can be moved from one source to other source, because this source, if you are seeing this, I can take the source to anywhere. I can able to measure the eddy current. Portable, complex shape can be inspected. So even this the test piece is a complex one, you can able to generate, because the only thing you have to do is you have to create a test source. So what are the limitations of this eddy current is limited penetration into the test piece. So we can able to study only the surface and subsurface. So before the current, if your test specimen is too long, we cannot read the flaws which are present at the end of the surface. Okay. If for reading the end surface, again you have to rotate the test specimen, which is a headache process. Next, only suitable for conductive materials. Yes, when it is a conductive, then only it can be able to get the electromagnetic field induced in it. So discontinuities are quantities, not quantitative indication. Qualitative we can study, but not quantity. How much depth, how much height, how much length, we cannot study that. We can able to measure how deep, how we can able to qualitatively can measure. Quantitative we cannot measure. There is in terms of we cannot measure. How much quality you can measure. Not suitable for large areas. Highly skilled labor is required to study the what do you say, the change which is happening in the eddy current or impedance which is created because of eddy current. To study that, a skilled person is required. False indication can result in edge effect and part geometries. No permanent records is possible. Okay. Interpretation of signals is required. The signals which are coming to out, that we have to study. Okay, so eddy current testing instrumentations are an oscillator, test coil, signal processing and filtering, and display. So first, this is my test piece. This is my oscillator. From the oscillator, where we are going to send the signal. So after the test probe is moving to rotate, so basing on the test probe, we will be having a bridge circuit which is trying to collect the signals from the test coil, and basing on that signals, we will be sending the signals to a signal processing unit and filtering, where the unnecessary and unavoidable signals will be removed, and that what is the difference or the net magnetic field which you are going to generate, we can able to study. So the oscillator provides an AC current of required frequency. Test coil or probe is nothing but the test coil serves as a main link between the test instrument and the test subject. It establishes a very varying magnetic field which induces the eddy current in the test object and increases the magnetic field in the magnetic material. It also senses the current flow of the magnetic field within the object and feeds the information to the signal. So that is what we have to see. Very important thing here. Sorry. So this. Uh, this it will try to sense the current flow and the magnetic effect which is coming because of the test object or within the test object, and feeds the information to the signal for analysis. Whereas in the signal processing and filtering, the eddy current testing and the signals of the defects may be corrupted by noise and other defect signals arising from the probe because of lift off. That is nothing but for moving, because of continuous moving, coming to and fro. There will be some unnecessary signals because of the electric magnetic field which is generated in the air. That can also be give some unnecessary signals. So that has to be removed. So unreliable detections should be removed. Next is filters are used in the eddy current testing to eliminate the unwanted frequencies from the receiver. Correct filters has to be used so that we can able to improve the visibility of the defect signals. There are two types of filters. One is a high pass filter, and the next is low pass filter. The low pass filter is used to remove the high frequency interference noises. The noise that comes from varieties of sources including the instrumentations and probe. Slow high frequency noises that has to be removed. Whereas in high pass filters used to remove the low frequencies which are generally present in the material or within the surroundings, that can be removed. Next is display. Display can be arranged from single LED and a meter readout or multi-frequency presentations on display. First type is nothing but detected display instrumentation. Dedicated instrumentations are designed or specifically applications and are useful for the able to perform the applications effectively. Examples of the dedicated instrumentations are crack detectors, coating thickness gauges, and connective meters. These are the few devices which we generally use for a dedicated purpose only. They will not be used to find other things. So these types of instruments do not provide the quantity of information and mislead the unskilled operator. Whereas in impedance, what we do is, so the amount of change of current which is going to be coming, that is impedance in the resistance. The impedance plane display instrumentation, each type material conductive deflects the display dot into an characteristic manner, facilitating the separation of variable and interpretation of signal. Impedance display instrument shows the variations of inductive resistance and resistance during the testing. So initially what was the resistance? After doing test, what is the difference coming? Basing on that difference, we are going to measure the flaws. Okay, what are the factors that will generally affect eddy current testing? Is nothing but material conductivity, permeability, frequency, design or geometry of the coil, lift off and skin effect. So lift off and skin effect is present in your syllabus. That is most important topics in your eddy current testing. Okay, so material conductivity. So material conductivity, how it is going to affect the eddy current is nothing but the conductivity of the material has a direct effect on eddy current. If the conductivity is less, the eddy current will not be generated. If the conductivity is more, then the eddy current which is generated will be more. The conductivity is often measured by an eddy current technique, and an inference can be then drawn about the difference of different factors affecting the conductivity, such as material composition, heat treatment, or work hardening. If these are done, so that may affect the conductivity of the material. When you are doing heat treatment process, because of the arrangement of what we say atoms, are the way the atoms are going to align themselves inside the surface, or the grain boundaries which they are trying to arrange themselves. Because of that, the conductivity of the material may be differed. Because of that, the eddy current will also get deflected. Next is magnetic permeability. This variable applies only to ferromagnetic properties. The permeability may be defined as the assay with which the material can be magnetized. As the material permeability increases, noise signal resulting from permeability variation increasingly they mask eddy current signal variations. This effect becomes the pronounced when there is increased depth. When the depth is increased, so this will be a huge problem will be created. The permeability thus limits the effective penetration of eddy current. So if the permeability is more, means so there will be a what we say, the pronounced effect will be there on the what we say eddy currents. Okay, so thus the permeability has some limit. Okay, the magnetic permeability of various materials which affects the eddy current test is given below. That is, paramagnetic materials such as aluminum has a relative magnetic permeability slightly greater than 1. Paramagnetic substances. Diamagnetic substances will have less than 1, whereas ferromagnetic substances will have greater than 1. Okay, you have to remember that. Frequency. So eddy current response ID greatly affected by the is greatly affected by the test frequency, which is generally taken between 50 to 100 Hz or 10 megahertz. So as the test frequency is increased, the sensitivity to surface discontinuities increases. test frequency is more. So then we can able to read the surface detection or surface flaws easily. Okay, permitting the increasing of smaller surface discontinuities to be detected. Small differences can be easily measured. Once the test frequency is decreased, we will go to slower values of the frequency. We are moving slowly. Frequency is nothing but the number of passes. So if you are moving slowly, so what happens means the eddy current penetration into the material increases, because when you are moving slowly, so the induction will increase to a lot to a deeper level. The induction of magnetic field will go into the deeper into the surface. So once the induction goes deeper into the surface, from the deep surface, the what we say eddy currents will be generated. So basing on that, we can able to identify the deeper flaws present in the surface when you are having a frequency slower. When you are having a frequency fast, when you are trying to move the test object faster, we can able to only study the surface discontinuities. Next is geometry of the coil. How the coil is to be present, how the coils, primary coils which you are using for generation of magnetic field, how they should be present. In real testing, geometry features such as curvature, edge grooves, etc. will exist within a part to be tested and will affect the eddy current responses. Sensitive to small surface discontinuities requires the eddy current field to be sufficiently compact, means it should be very small. It will be adequate, distorted by the discontinuity. Also the penetration requires the eddy current field extended to requires a deeper specimen. The thumb rule is the eddy current penetration limited to the depth of the specimen. So the thumb rule is nothing but Fleming's left hand thumb rule is the thing where it is saying us to what extent the eddy current penetration is limited into the depth of the specimen. Next is lift off, proximity or lift off. Lift off is nothing but how close you are going to take the specimen and how you are going to lift off. The distance between the surface coil and the test surface is nothing but called as proximity or lift off. Since the flux density increases exponentially with the distance from the test coil, the amount of lift or the separation between the coil and test specimen will have a great impact on the sensitivity of the induced current. The closer the coupling between the coil and the specimen, denser will be the eddy current develop. So that thus the more sensitive to the test. Okay, so too much close if you bring, the induced current will be going to deeper into the surface. If you are not bringing closer, if you are taking just light, so only the eddy current will be generated only on the outer surfaces of the specimen. Because of that, you cannot able to study the surface defects inside the surface. Next is depth of penetration. So the eddy current concentrate near to the surface adjoint to the excitation where it is going to excite. So if you are bringing near to the surface, it will be getting only on the surface excitation. If you are taking too much close, it will be going deep into the. Okay, the strength decreases the distance from the coil, that is eddy current density decreases exponentially with the depth. This phenomenon is called as skin depth. The skin effect arises when the eddy current flowing in the test object at any depth produces the magnetic field which opposes the primary field, thus reducing the net magnetic flux and causing the decrease in the current flowing as the depth increases. So the current will be decreasing as it goes deeper into the surface. The standard depth of penetration when eddy current is used is 37% of its surface value. What is the present on the surface value? So if you go to the deeper, so it will be like 37%, still 37% it can go. Okay, so with this we can able to stop. Still there are few further topics within next class we can able to end the second unit also. Okay, thank you.